Hi, everyone. I am going to show you how to solve real life systems of inequalities graphically. So you have to be able to read and translate because usually they ask you to write a system of inequalities like they are here. And so you have to be able to read the words, translate, and then solve it graphically. We can use our calculators to help us. So the example is here. Olympia High School is having a concert and can sell at most 120 tickets. Some were adult tickets, X, and some were student tickets, Y, which is really nice that they gave you because you can also find that info down here. Look at the X and the Y axes, and you'll see what they stand for. The adult tickets cost $2. So now we're talking about money. The cost of an adult ticket is $2. Student tickets are $1. They would like to make at least $160 from the concert. So we have number of tickets and we have cost. So for the number of tickets, I'm writing my inequalities now. I know that the adult plus the student tickets must be at most 120. For the word at most, I always think 120 will be the most, which means it needs to be below that. So less than or equal to 120. It can be equal to if it's at most. Then I'm going to read about the um, cost of the tickets. So cost inequality will look like this. The adult tickets are $2, so $2 for every adult ticket plus $1, you don't really need to put that one there, for every student ticket. And it says that is at least 160. So I always think 160 is the least it can be, and it's going to go up from there. So that would be greater than or equal to 160. So there's my two inequalities. And if you're good with your graphing calculator, x plus y is less than or equal to 120 can be open a new graphing screen, delete your equals. You can graph it like a relation. So x plus y is less than or equal to 120. And don't worry about what my screen looks like right now. Hit tab and take a look at your other equation. 2x plus y, oops, I opened the wrong thing, but same idea. Oh my goodness, now I'm opening everything. 2x plus y is greater than or equal to 160. 2x plus y, I don't have to say 1y, but is greater than or equal to, make sure you choose the right symbols, 160. Enter. Wow, this does not look good at all. Let's use our trace feature. Menu, trace, graph trace. So that takes me right to the y-intercept of my first graph, and it is 0, 120. The beautiful thing about that is, now I can go to my graph, and it's not letting me scroll down, and I don't know why. I can go to my graph. Yeah, cooperate with me, screen. There it is. I can go to my graph, and I can plot 120 on my first y-intercept. And then if I continue to trace to the right, I can find other nice points. So you know what? This is going to take me a while. 3, 117 was one that I just saw. So 3, 117 is another point. Oh, wait a minute. I noticed my scale goes by tens. So on my calculator, I should probably do menu, trace, and change my step to go by tens. And then continue to trace to the right. 10, oh, my screen's going crazy. I love when this happens. This is so much fun. So I'm going to slowly go back to where I was. Oh my goodness. That's my crazy voice, by the way. Did you hear it again? It came out twice so far. 0, 120, 10, 110. I like that point. 10, 110. And then go back to your graph, trace to the right, 20, 100, and so on and so on and so on. 20, 100. Once you get the pattern, and you realize you're going down a box, over a box, you can just keep your pattern going. Down a box, over a box, down a box, over a box, down one, over one, down one, over one, down one, over one, down one, over one, down one, over one. Now let's see, should this be solid or dotted? Both of these lines should be solid. So I'm going to make a solid line connecting these points with a straight edge, but I'm not, in the interest of time, using a straight edge. So there's my crappy line, okay. And then it says we are going to shade, according to my graphing calculator, I don't even have to think, the pink area is below the line, so I'm shading below the line. Shade, 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 shade. Now to get the other graph that I came up with, I'm just going to use the up and down arrows to get to the other function. Do you see it over there? It's in green. So currently I'm at 2120. I'm going to left arrow, and I'm going to try to get back to the y-intercept, which is 0, 160. So on my graph, I'm going to put a 160 y-intercept. So up and down switches between the graphs, and then you can continue to use trace. So right arrow, 10, 140. And now I'll have a pattern to work off of. 10, 140 is right here. So now I'm going down 2, over 1, 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 down 2, over 1. And I'm going to do a solid line again. Again, use a straight edge, but I'm not, in the interest of time. And then look at your graphing calculator. And if I can get to the other one, you will see the two of them together. And you'll see now that the green one, I shaded above. So back to my picture. The green on there is red on here. I shaded above. Where do the red and black lines overlap? Well, I see some overlap down here, right in this area. So I put a big S there because that's where the solutions are. That's where the two inequalities are both satisfied. You're going to keep your tickets where you wanted them and your cost where you wanted it. If you sell or purchase a possible combination of ticket sales that meet both requirements, I'm going to pick 90, 20. That would mean 90 adult tickets and 20 student tickets.